Yeah, hello, my name is Irina. I'm working at DevFox already quite a while. And yeah, in DevFox, we are developing languages for our clients. And beyond that, we develop a language engineering framework, Langium. And exactly about Langium, yeah, we have today our training session. So uh, during this training session, I tell how to use Langium and yeah, how you can build your own language from scratch. So uh, maybe you ask questions for what do you need to create your own language. So our clients really prove that you need to do it, and I give you some examples where you meet such languages. So, for example, it can be some small language for databases, so SQL, or it's already not very small, but it's a whole family of languages for manipulation with data. So it can be MATLAB, that is also some extra language, some domain-specific language that allows you to uh, make matrix programming. It can be also some bunch of languages that help you to build your project. So each language has such systems. So, for example, Java uses Gradle, and yeah, Haskell uses Stack, Scala SBT, and many other such things. So um, one more example of such languages that you may maybe want to create is LaTeX. So it's also a pretty big language, but it's also language that allow you to solve your problems. Finally, I hope you already got some feelings that you want to create some own language for your some concrete goals, and we can speak about what you need to do if you want to create your language. So you need to satisfy some different things. So first of all, you want to have many language features, such like parsing, validation, linking, scoping, interpreting, and so on. And in addition, you need to support some IDE features. So it's about how users of your language can manipulate with your language. Of course, we all want to have very nice IDE with which it's very nice to and comfortable to develop code. So this is why we have to support users of our languages, and yeah, we have to support such common things like find references, go to definition, naming, code completion, hovering, and many other things. So, and now when you understand how much things you have to do to implement your language, you maybe ask yourself, yeah, how to implement all this. So it can be very nasty to implement all this manually. So here Langium can help. So during this session, we are speaking about what Langium is, goals of Langium, and finally, and it's the biggest part, we are speaking how to write your own language using Langium. So it will be the biggest part where we step by step from scratch create our own language. So our first step is discussing what is Langium. So it's language engineering framework, a spiritual successor to Xtext. It uses TypeScript and Node.js. It's powered by Chevrotain. So with all this, you can get high out-of-box functionality, and this is benefits of Langium. So, and here we smoothly come to the question, what are, how all this working? So, actually, Langium can build pretty powerful things just from scratch. So you have your own language, you already have ideas, you describe how grammar of a language looks like. So it will be just one file. And from it, Langium can generate feature services. So again, it's like some language features like parsing and so on. So as well as some IDE features like scoping, find references, and so on. So all this will be generated by Langium. And then when you have all this, you can try to write something in your language. So you take code in your language, send it through your feature services, and then finally you get your everything. So you see um, uh, full powerful support of your language in the IDE and all the things to Langium. So next thing that we should speak what goals of Langium. So you may maybe know about other language engineering frameworks, and yeah, they have benefits, and uh, Langium has own niche in it. So and one of goals of Langium is low barrier to entry. So Langium initially was designed such way that you can create your language just from scratch, very simple. So you have your grammar, uh, and immediately gets your support. Meanwhile, you don't need to spend very much time on it. So as benefits, yeah, Langium is very close to TypeScript. So if you're TypeScript lover and don't want to go away from your favorite language, you can stick to it. Uh, and yeah, it's very quick to make your language working. So you have idea and have support. So another goal of Langium is to be lean by default. So it includes everything what you need and runs everything out of box. So we will really see how it look like. So all this possible again thanks to default feature services. So Langium has default implementation of all necessary services for you. So you have grammar and you can customize also some validations for your language. You write some code generation and you have everything what you need. So, but of course, you may want to have something else. So, uh, yeah, how we know if it would be possible to create some default implementation for everything? Yeah, maybe programmers wouldn't exist now because it's too many problems that you have to solve very specific way, and this is why Langium provides very comfortable way to create your custom feature services. So you don't need to implement everything by yourself. You're still able to use some default services, but you can use yeah, your custom implementation for cases where you really want it. So some common thing that you maybe want to have customizable is like scoping, and today we also take a look at it. Um, yeah, so we took a look at goals. Now it's time to try how all this is working. So we try to write on language, and this is our program. So it's pretty much text, but it's not really necessary to read all this. So we just go all together through it with code, with yeah, with Langium, with everything with me. So, mm, but we should read what we are doing. So the first thing what we do is we discuss ideas. So idea of language. So it's really from scratch. So when you have only overview of your language, then we try to design your language, or that is proposed now here. So we discuss how you can think about syntax. Then we try to sketch our grammar with Langium. And surprise, we already can deploy it. I find it very nicely. Especially it's nice that you can so fast, it's so simple, see how your language would look like. So next thing, we try to refactor our Langium file. So it's exactly where grammar of our um, language will exist, and speak about workspace management, and take a look at some grammar related feature like cross-reference. Uh, then we speak about yeah, default implementations of language protocol services. So the most interesting from them are scoping and completion, and try to customize some of them. Finally, we take a look at code generation and shortly take a look how to contribute in Langium. So we're ready to start. And before we really started, I want to mention that, yeah, now we come to the main part, and please feel free to interrupt me and ask your questions. So, okay, our language. So our language for this training session is called SQL. So yet another SQL. Yeah, and surprise, we try to make one more SQL. And in this moment, we have to think about requirements. So how do we want to see our language? So which syntactic things we want to see? Uh, what is extremely important for us, like IDE features, and how do we want to get something useful from it? So about syntax requirements, it's very simple language. So we want to create and fill our tables and select some columns from this table. ID requirements is very classical thing. So we want to have highlighting, of course. We want cross-reference features like go to reference, renaming, and some other guys from this area. We want to have a nice scoping, completion, and validation. Yeah, it's everything very nice. And finally, we want to be able to convert it in real SQL. So it's a moment when we finally can start design our language. So imagine that it's a piece of paper where you just have brainstorm with your colleagues or alone, how you like. And now you can just put everything what you want about your language. So here you can see two options. They are different. One, the first is has really SQL-like syntax and play with uh, something with declarative uh, style, and what you see on the right side, it's something that tries to play with imperative style. So it has variables and so on and so on. So it's sometimes very nice question what to choose. Yeah, and this is, in my opinion, one of the most interesting moments where you can have this brainstorm. It's really very exciting. So I propose that we would work on the right side because it's just something what you and people who play with databases are used to. So, and right side, this is what we implement. But yeah, I want to remind again that this moment where you can make free your fantasy and do whatever you want. So if you like right side, we start. So um, and that's the moment when we try really play with it. And the simplest thing what you can do when you want to try to make your example, you can just copy what you have here. So that's already scratch how you want that your language would look like, and paste it in your in playground that is in Langium website. That's how I propose to develop our language today. So that's what we want to get. That's on our right side. On our left side, you can see some placeholder for grammar where we can put our grammar. That it's really cool. We can really develop our grammar now and see how we get everything for our language. So on the left side, it's still some placeholder example hello world. So we will not take a look at much because it's not very important. Yeah, and we can start to implement our language. Let's call it SQL. And then we have to describe something. Let's make it working. Everything what I done now, I just made our grammar not broken, that we would have our example again here. So let's take a look in our example and start to support the syntax word by word. So what we can see here is that we have some different constructions, and in general, three types of constructions. So we create table, we insert some elements in table, and we select some columns from this table. So And if you take a look again in this example closer, that's some tables that contains languages and year when this language was released. Oh. Okay, so now we can start to describe it. This first construction that we have here is creation of table. Well, yeah, create table construction. So, and we can describe it with a rule. Yeah, let's also. So, before I dived in something deeper, yeah, I should tell about this syntax that we use for Langium grammar. So each grammar starts with keyword grammar and then name of your language. Then you have many rules. So currently we have 2 rules here. And rules for terminals. So here is a bit more rules. So each rule has a name, and then a comma after which you put a body of your rule and description what it has to do. Also important moment that one rule, exactly one has to have keyword entry. It's a rule using which parsing will start. So also you could notice that I already used some constructions this called assignment. So it means that we want to keep some information about what we parse. So this is exactly what will be transformed in some our node in our abstract syntax tree, and this is property with which we will manipulate. So currently we started to describe our table. So let's really describe it, and we can see that it starts not with name of the table. So, but it starts with keyword. So let's really do it step by step. So we see that we need keyword create. Let's do it. Leave it here such way. Then we need keyword table. Then we need name of our table, and this is how it is. We will keep it in property name of rule table that also later will become a type table. And here you can see that we use some terminal that says that we're expecting some identifiers that will be parsed this way. So then we see that we're expecting some parentheses. So let's also put some parentheses. Okay, that's also here, and we need also, what is it? This symbol. Then we can start to describe our columns description. So you can see that column contains two things, name of the column and its type. So let's really do it such way. So we need some new rule. Let's we'll call it column. And then we want to have name that will present also by identifier. And we need type. Type can be number or text. So let's do it also such way. Oh, sorry, we need. That's all. I hope you see some constructions that you can remember from something. So it's basically BNF foundation what I use. So we have here alternatives, and later I can demonstrate that we use also asterisks, pluses, and so on to parse some elements. So okay, our column contains name and its type, and to be a bit more proper, we can put it in a special rule that represents exactly all of this. And we can use it here too. Yeah, as you may notice, Langium says something about invalid things. So when you use your rule only with some keywords, you should use some concrete type. Such rules, they are called data type rules. It's rules who don't use assignments. And in this case, you really have to specify which type of all these constructions you expect for TypeScript. So. Okay, and also you could notice that we have some strange highlighting here, despite its name of property. In this case, you need to use this. So the problem here is that Langium uses type for internal things, and if you have matching of some property names or rule names that are reserved, you should use the symbol to allow it in your language. Okay, so now we can use our column so in table. So we don't want to forbid to have 0 columns. So this way we say that no columns can come, and then we start to parse our columns. So we know that columns can be many. And also we know we want to keep them, because when we don't keep them, we don't have them in our resulted type. So, and finally, since we have many columns, we want to keep them in some array and not just one variable. So, problem that you can see here is that we have some error about this comma. This is why, because we don't parse this comma, so let's parse comma. Yeah, okay, that's working. And now finally we can use our table inside of our construction, inside of our first rule. So let's do it. We expect that we can have some tables, so let's put it like some tables. Yeah, this way. So again, I make a remark that we can use here plus or asterisks, or if you want to parse some constructions of this type. Yeah, and if you want to keep it in some variable, you have to use this plus here. That actually means that, okay, I want to collect all guys of this type inside of this variable. Okay, so let's continue to describe our all other things. So we have some problem here. Let's come back to it later, because we can. So I, in general, propose don't spend too much time on it and come to already real example to our VS Code. So I just show how all this grammar will look like when we would finish it. So yeah, and this is how it looks like. I can just copy and paste here. Imagine that we wrote it right now. And you can see that all our this example is working. So I think it's very wonderful. So you can already play with it and see how it can look like. So in addition, you can press here some button and you can see syntax tree. It's some super feature. I find it like super feature where you can really take a look how this your program will look like in abstract syntax tree. So we can see everything here. So we know that we have here one table, two insertions, and one selection. And this is exactly what we have here. So we have some common construction, SQL. So this is our rule that we have here. Then this rule can contains many things of these types. So we have tables, insertions, selections. So, and this is exactly what we have here. So we have a node that has type YASQL, and then has property tables, as property insertions. Yeah, it's two of them, and has property selects. So yeah, it's exactly what we want. So tables, it's also it's a list because we allow here many tables. And yeah, we have only one table, and you also can see that there's a type, there's name of this table, so that's what you can see here. We have columns. Many columns can happen, so we can have many columns here. Yeah, and finally, we can take a look and insert. So we skip it for our writing, for writing our grammar. So we can take a look here and it close it. So insert something that also has keywords. So this is how we want to have it here. We have here name of a table. This is a table where we want to insert. And finally, we have some also columns where we can put our information. So you can notice that we have some different types for columns. So one column called column declaration. It's for the situation where you want to use it in your table when you declare your columns. And another one is a situation when you want to put your values inside. So in this case, we use full column init. So you can see the difference here very easily. So here we expect some type, number or text, and here we expect some concrete values. So what can be identifier or number. So let's take a look what we have here in our ST. So we have here two insertions and one second one. So, and this is why we have here also two items inside of our insert array. So yes, okay, it's working. It's wonderful. And again, it has type and it has all all properties that we have here in our rule. Okay, and finally selection. Syntax that we use is from some table. We want to select some column. There's only one column. So, and this is exactly what we described here. Okay, that's also working. So again, it has its properties, has type, everything is great. So let's try now to do something here. So in the moment when you finished playing with the playground here, you can start your real development with Langium in VS Code. So, and the question how to do it. Yeah, so actually it's very simple to do. There's some wizards that help you with it. So everything what you need is just call it. So I go in my developer folder and can start at your Langium. So because my your Langium is already installed. So and then I can set up some settings of my language. So I want that extension that will be generated from my language would call this way, YASQL. Name of my language, such one, and here I can point out some extension. And then, I can set up how I want install which extra opportunities I want to have in the generated template. So currently Langium provides some such things. So for example, some code for VS Code extension, for generation VS Code extension, code for CLI, and finally code for web worker. So I will not wait. Okay. Yeah, of course it has conflict because I created in the same folder where I already have my SQL. So after pressing the last button, you can see how this project will be generated. And okay, let's imagine that it's already generated, everything is okay. And we move our a bit in the future. and we just open this file from open our project, open our freshly generated project. So um, uh, I tell a bit about this repository. So basically, this repository that exactly proposes different things for your SQL, and now we will, of course, it already contains all full language implementation that we are going to take a look today. So we just go step by step, commit by commit, and here I'm in the first commit that's called init and deploy. So this project contains initial setup generated by a human generator, and it contains our grammar that we only wrote in our playground. So, okay, we can start to do something with it. But before, I'd like to show what is in this project. It's many files, and yeah, let's take a look how it looks like. So here we have our configurations of VS Code. So here are some launch configurations that you can see here. So we can start our language extension. So actually, it's the same what we could see in Playground currently. Let's come back. From more interesting things, you can also start your language in Playground. So I just press here. Wait a bit. Wait. It's not working. Sadness. Need to take a look at some setups. Yeah, okay, I understand. We need to drop it for now. Don't have these errors. Okay. You wouldn't have these errors just because you would have a freshly made project. So just close your eyes and don't take a look couple moments. Okay, I make also our okay. Be sure that everything is okay, and currently we have no errors, so we can try to start it. It said the second time. Okay. So we can come to it later when I unfold more commits. So currently we are sticking to taking a look at the project structure. So again, we have here two configurations. One is about extension, and second one is about deploying it in the web. So basically, it has to work out of box for you to work out of box. Just believe me. Here I add already also example that we took a look. It's just in folder examples. Then we have folders source. So here you can see how extension. Yeah, it's not what maybe important for you currently. And in this folder you exactly can have your language. So this is a file that contains your grammar. This file that in the future will contain some validation. And this file that contains some different language services for your language. And these two files are responsible exactly for starting your language as VS Code extension. So this file and this file as for starting your language and web. So also we have some folders. This folder is necessary. These two folders necessary to have for having your language in web. We can have some test folder. And what is also important for us is Langium config. So it's configuration file that has all information about our language. So as you remember, we just created everything using our human generator. We put language name and some other things. So that's exactly what we have here. So we put our language name, how our what is a language ID, how it would display for like some Discord extension. Extension of files for our language, and also how we want to generate mm, our highlighting. So currently we have here two options like TextMate and Monarch. One of the most interesting thing here is also some configuration about case insensitivity. So you could notice that SQL requires you very often something with capital letters, but you maybe don't want so write all the time with capital letters. And if we anyway generate some SQL code from our code, we can allow using some not capital letters. This configuration says that keywords in your language can be typed like capital, like not capital, and everything would be parsed. So, example. If you take a look here, if I try to type it here, such way parser just will not recognize that insert such way into insert such way is the same word. So when we have this enabled, I try extension. So you can see that we can type it such way and it's working. Wonderful feature. Okay, so when we finished with it, we can go to our grammar and do something more interesting. So I unfold one more commit. So what we do next is something about workspace manager. So we will take a look that it exists here. So before you could notice that we had only one Langium file. And what this commit does, it splits this one file in some files. So we have now 3 files. I didn't add any new things here, any new rules, but we split our grammar. So this file now, the main file for grammar. So here you can put, because it contains a rule that has entry keyword. Also, you could see that we imported some other files. Terminals, that's a file that contains all terminals. And also a file that called operations. So here a description of our insert and select operation. So, and Langium allows you to have some Langium files. And again, it's done thanks to workspace management. So you can modify these files and they will be automatically tracked and updated everywhere. So for example, if I take a look at this file and try to use this, to understand that it lost its rule for who it was, to which it was referenced. So, and again, if I come here and rename it here, you automatically see some updates in referenced file. So let's give everything back. So I find that it's I think I'm fascinated by each feature of Langium actually. Okay, I discard my changes, so don't have anything. And now we can come to the next commit. And this is commit about cross-reference and scoping. So we will try to add something more interesting in our language. I start again our extension. So you could notice that sorry, one moment. You could notice that before we couldn't do anything with this. So usually, in normal languages, if you press some names, they can lead you to some declaration or to an opposite to referencing values. And here we can't have it unfortunately. So it's sadness, but again, Langium provides feature that allows you to do it, and I am writing a branch that allow you to do it. So basically, what this command does, it demonstrates how modification of grammar will give you opportunity to have cross references out of box. So we have our operations, and we want to have that we want to have that this but we have our language name, that it would be not just a name, but if I click here, it brings us to exactly a moment where table was declared. So, and for that we can use the syntax with square braces. So to make it working, we need to regenerate our Langium and rebuild our everything. So, and now it's working. So again, everything what I did that it would work, I just add this square braces. So how does it work? Yeah, here. So we have our table. We have some name of this table that was declared somewhere else. And at the moment when we want to declare our insertion operation, we want to use here not just ID, not just identifier, or not just the name of your table, but reference with this square braces to existing table. So such construction will tell Langium that you want to use not just a name, but name of something that was declared somewhere. So, and this is why we have it here and there. So nicely. Second moment that we should discuss is is scoping. It's also a very interesting moment because how it's working, how really many things depends on scoping. So and including references. And now I can demonstrate you how everything nicely working. So including columns. So I can reference here, and columns will work for referencing too. But it's it depends how your scoping is developed, how the scoping is working. So, and currently we should take a look at how scoping looks like for our language. So here we had to override some default behavior. So by default behavior of scoping is follow who belongs to which node. So what it means, scoping in Langium by default implemented like some blocks. So it's like example that I can bring any language actually. For example, TypeScript. So you can see that this is one scope. It means that all guys, all nodes, everything what declared inside of this will be visible to each other. But if I try to use, for example, container variable here, I will not be able to reach it. So it's all because of scoping and how it's working. So it's called lexical scoping because it's based on some constructions. So it's everything very wonderful. So, but it's not really suitable for us. And I show you why. So basically, I just copy this or comment this, and this will demonstrate that our yeah, cross-references will fail. So again, I am making npm build. So by the way, we maybe have already, yeah, you can see what happens. So before everything worked nicely, but it worked nicely exactly because we were able to override our scoping correctly. So scoping by default would work the next way. So you have our languages or our table, and these properties of this table are visible only inside of table definition. So only inside of this node. And the same here. So these guys have scoping only inside of this braces. So or not really braces, but inside of this node, and so on and so on. So to fix this behavior and get this behaviors that we want, so that this properties that you uses for insertion would see that it's the same properties that you have here in your language in your table, you have to redefine the scoping. So let's take a look how it's done. So for that, we need to make two steps. The first step is overriding default scope provider. In our case, it's scope provider. Yeah, and we need to override method get scope. So what it does, it takes our reference info and gives back scope. So we have to create other behavior for the situation. We take a look who is our current node. So basically, this method will start for each node that we have in our input st, and we have to give back another scope. So what do we want? I open our grammar a bit here so that it would be easier.
Irina, sorry to interrupt you.
Yeah.
There are a couple of questions in the chat.
Yes.
If you want to address them, or even if you want me to ask them for you,
Yeah.
would this help? So we have a question from Avi Sheikh asking, it may be trivial, but does cross-referencing with parentheses, I believe it's what he means, also shows error if you are referencing an element that wasn't declared?
Yeah, I show this error. Do you see this error?
Yes.
So the question, why does error appear or order or?
Avi, could you give a bit of insights into what you mean by your question, please?
I just meant that if you write insert into languages one, for example, before you define create table languages one, and you define just languages, right? So if I write insert into languages one, will I get an error?
Sorry, could you repeat the question because I don't get it.
Yeah, so you on the top of your script here, you have create table languages, right?
Yeah.
So we created an instance of languages.
Yes.
And now you have insert into languages, right?
Yeah.
So what happens if I write insert into languages one?
This. What happens here?
Yeah, instead of languages, just write languages X or something like that.
Okay.
So will I get an error? Yeah.
Yes.
Okay. Just I said it might be trivial, but thank you. Okay.
Yeah,
Wanted to make sure.
the moment is that if you are satisfied by a default implementation of scoping, so if it's suitable for your language, it can work. Everything can work by default. So basically, how our languages, this and this construction, are existing in this common scope. Yeah, this is our program. So and for this reference, this definition is visible. So it will not be an error. But again, this and this create an error because this will be inside of scope of this node and this inside of scope of this node. So Langium default implementation stick to nodes that we define in our grammar. So, and we need to define this behavior, and this what we will do. So what we want here, we want to tell, so when we want to resolve this reference, so this reference, and we want to resolve it, we want, we will call this method getScope. And in this moment, we want to give back a really bunch of things that can contain our reference. So in our case, what we want to do when we want to resolve this or this, we want to go in scope of languages inside of this and want to give back this guys. So we want to say that this guy refer to something what is inside of this, inside of our languages. So, and this is what how we redefine our our scope computation. So I continue with scope provider.
Sorry, Irina, I have another question if it's a good
Yeah.
timing.
Yeah.
Yes.
I
So we
think
have a question from
I think that question's just been answered, really. I think so that's fine.
Okay. So thank you very much, Irina.
Okay.
Thank you, Stefan.
Yeah, so that's how you can redefine this getScope. Again, what happens? So when you want to resolve your some guy, so for example, you want, again, I open it. 1 moment. Yes, I can open it such way. Yeah, when you want to have it such way, you say that you don't want to have a name of you don't want to declare some column, you don't want to parse some column, you want to have just a name of somewhere declared column. So, and in this moment, when you want to resolve this reference, what is here, you want to get some list of possible options to which you can want to reference. And so in this moment, this method will be called, and it will be called for nodes. And handling them, you can give what is necessary. So let's take a look. So here we want to handle our column init node. So, and if something what came to us for resolving our getScope is column init, so we want to catch name of the table. So how do we do it? We know that column init can be inside of insert, only inside of insert node. So we catch it using property container, and then we can catch a reference to the table. So it's what we know, because insert node has property table. This reference is resolved because they're in one scope, because insert and table definition is in one scope, so we can get here name of the table. And finally, if we found this node, we can catch all columns from this table. That's all, and it will work. So similar things we have to make with select. Here we have also some column name, again not column but reference to existing column, and in this case we want to handle this property that it would be able to get correct scope. So we take a look that we're working with select, then we take a look at what we're interested in, this reference that came to us related to property column. Then again we can catch table from our select, so it's select. And then we can, again, catch all columns from our table. That's all. And in case if some other types of nodes came, not column and not this, we can just call parental scoping, because it's not so bad. It's actually what we also want. So thanks to this, we got our correct scope computation with some not so much modifications, and it's working. So I start everything again. So And now it's working. Yeah? So I reference here, I reference there. Yeah, everything's wonderful. I can go here, I can go here. Yeah, it's perfect. So our next step, our next step is dependency injection. So the moment, how I mentioned, we need to make two steps that some customization of our default services would work. So first step, of course, it's redeclare of some default implementation. But second step is tell Langium that we want to use our implementation and not default implementation. So that's important moment. And you can notice here that I have this. And YASQL scope provider is exactly what we use. Now, so let's take a look at this file. This file, YASQL module.ts, exactly managing which implementations of all the services will be inactive for your language. So let's take a look what we have. In general, we have two types of all models. One is called shared modules, so or shared services. Okay, shared services. That's you will touch it for the cases if you want to have some project where you have some languages that have to communicate with each other. So you have some shared things that can be used by these languages. So for now we don't touch it because it's a bit beyond our current goals. And second thing, the most important that what we touch is just usual services. So usual services for our language is this. SQL services, they consist of two parts. So it's Langium services, basically the services that have default implementation, thanks to which everything is working by default. And also you can add some edit services. So it can be some validation, for example, or it can be whatever you want actually. You can make everything. But for the case if you want to do something with Langium services, so again, for example, customize default behavior, you use this. And this type. And finally, you define such construction. So again, it's actually generated by default. You just add your custom implementations here. So that I want to have here this construction. So how it's working actually. Langium has default implementations and interfaces for each of the services. And everything what you need to do if you want to put your custom implementation, you need to implement something what will satisfy this interface. So now we satisfy all this interface. So especially that we extended our default scope provider here. So everything is okay. And so thanks to this, everything is working. So now we can train a bit this new knowledge and can try to customize another service. So I travel a bit further and and we have here one more thing. So you could see how it appeared. That's one more service, one more service that usually has can not have implementation. It's not so important service. It's basically semantic highlighting. But we won't redefine it because we can and because our highlighting will be schöner, more beautiful. So what this does, it tells which nodes with which properties have which type. So types can be different, like parameters, type. It's also called type. But I think it's simpler. Just take a look on it. So we have this file. It's called semantic token provider. So it implements abstract semantic token provider. So it automatically means that we satisfy our interface provided by Langium about the service. And finally, we need to define this highlight element method. So what we are doing depends on a node that came to us. So here, this method will be started for each node that you have in your grammar. Depends on which node comes to you. You may want to color a different way. So we have type. So it will be some color of type, property, and parameter. So let's don't speak much and just try it. Yeah, this I think it's more beautiful. So what we did here, we told that column names would have this color that it has type of property, and that this has type of type. This is why it got this color. And finally, that this has type of parameter. And so everything became different colors. So it's done just by selection by type, and then you can use acceptor. Here you need to pass your node property that you want to color and type. So this type is exactly which type is type of this element. Okay. So you can ask maybe how it relates to our other highlighting. By default, we are generating text-made highlighting. So this is what we will have immediately. It highlights our keywords and so on. But when your project becomes more advanced, you maybe want to have more colors. And also you could notice like a difference between two of these highlightings, that text-made highlighting is working faster. So you could notice again that when I started, semantic highlighting appears not immediately. So that's okay. Next thing that we should discuss is validation. So here again we customize something. At the moment that Langium of course can't provide you default implementation of validation, because it's too specified thing. You never know what user can want to validate in own language. So that's our validation. But to be complete, again, let's take a look how we embed it in our module file with all our other services. So we say that this is a type of our added services. So we told that, I will have this service for validation. And then when we define all services for our type, so this type here, so we can just add our service with our implementation. Okay. Let's go to our validation. Here are 4 validations that I added. I hope they seems to you also very logical. So the first validation, we want to force user of our language to use capital letters for table names.
Irina, could I stop you for a short minute?
Yeah.
We have a question in chat from Stefan Chala, if I can read it out for you. Are there generators for scaffolds for validating semantic highlighting, etc.?
Generation for semantic validation.
So if you have a Yeoman generator for setting up the basic project structure.
Yes.
When I then go further and I want to add things like semantic tokens or validators or so, do I have to remember what the basic structure of those classes needs to be, or are there sort of little extra Yeoman generators that I can just trigger to give me the scaffold and add it into my project?
No, with your mention generator, you will have everything what you need, actually. And
sorry, Irina, that's not true. So no, the human generator won't enhance existing projects.
Right.
And the normal one just really gives a very basic setup. which does include validation, but
Yeah.
not more
It-
advanced services.
It includes setups for validation, but it's empty. You need to define it by yourself. So I mean,
Yeah, right. But that's what the scaffolding is for, right?
yeah.
But that was that was the question. Is to you get the basic scaffolding basically, and so you get the basic scaffolding for validation in the initial project generation. But if you want to do these more advanced things like semantic tokens, etc., you've got to sort of go look it up in the documentation what the structure of the class needs to be, and then hand code that essentially.
Yes. It will not be in your generator, but I can say that it's really simple. So
Yeah. That's fine. Yeah. I just wanted to understand. Thank you.
Yeah. Okay. Thank you for the question. Okay, I can continue with with validations. So let's take a look how validations are working here. So basically, it's some service that allows you to register your validations for different nodes. So core thing that is interesting for us is this. So here's a list of checks, and on left side you can see something very familiar. So basically, it's some map from name of your node that is generated from a grammar to list or one, can be how we want, validations related to this node. And what will happen here? Validator will apply these validations exactly to nodes that keys in this map. And here we define our exact validator class, and this is exactly what we also put in our module here. Yeah, it's the same. So we need to register it and have it, to mention that we have it in services. Okay, sorry, it's wrong. This. Okay, let's take a look at validations. So our first validation is working with tables, and it wants to check that name of a table starts with a capital letter. And it gives the warning if it's not such way. And so what you need to do is check some condition using your node. And then if you catch some error or warning, you understand that something goes wrong, you can use this acceptor to which you need to pass type of wrong thing, so how bad everything it is. So then you give a message, error message or warning message, I don't know, and then you need to pass information. What has to be highlighted with this beautiful curvy red or yellow lines. So we want to highlight table with property name. So we want to highlight property name of node table. And before we take a look at further, let's build it and take a look. Oh, sorry. Yes. Take a look. What looks like an hour. So I try to make it a small letter and we will get warning. It's working. And you can see that we have this highlighting exactly for this property of our table node. And by the way, I can demonstrate something more. You could see that as soon as we use this not capital letter, we have some other errors, and you could see that we can resolve these names, because of course it expects some table with name with capital letter, and of course it already can't find our property names. So that's what we want, what we expect by this. So now let's briefly take a look at the validation. So you can check also that table has at least one column, that no tables with two the same names, and you can also check types of columns. So you can check that you add that information that you add in your table corresponding to types. So if you want to add column add information in column that has type number, you have to add numbers. If you want to add information in column that has type text, you have to add text. So, and this is exactly what happens now. We get validation is with not true. So let's try to add here number. We expect text, but yeah, so we got our error. Let's also create table with the same name. So we got our error too. And finally, let's try to create table with 0 elements. So table has to contain at least one column. You could see that we also broke this again, because of course it can't find already some elements. Okay, I think we are very nice. We finished today also with validation. The last thing I suppose that we need to do, almost last, yeah, it's code generation. So I want to stop everything, because yeah. Okay. This what we are doing, what we will do now, we will try to add CLI that make code generation from our code. So of course, what we are doing, we just describe text and how to handle it in IDE, basically. But we want to have something functional. And for that, the simplest thing what we can do, we can just generate some code in real language. And we do it with SQL. So we generate SQL code. And what I would propose, how to do it. This is a code that you want to get. This is our usual code that we provide for our language, and this code in SQL that we want to get. So this is what has to be transformed in this. And for that we will just to make code generation, and we do it also with CLI. CLI can be generated templates can be generated with your main generator. So here you get this CLI util. Some doesn't matter now, some functions that help you to support your CLI. You get also this file. It's exactly starting point of your CLI, where you can define parameters of your CLI and so on. And finally, this file that will be the most interesting for us, that's what we use for code generation. So, and in addition, we need to have, of course, this file to that we are able to start our CLI. So let's try to make CLI. By interface of our CLI, what we expect that we have some we can start it. Yeah, okay. We can start it, and you could see what exactly we can do with it. So we have some options. We have some parameters, and here we have some functions that is the most interesting for us. This command generate. So it generates SQL code from our custom SQL to real SQL. So let's try to use it. So I put here generate, what we need to pass here, we need to pass here some file in our language. So let's do it. We did something. I need to take a look what we did. So basically, we passed here some file in our language, and we got file in SQL, and it's working. And let's really try it. So I copy it and paste it in some online SQL thing. So we'll try to do something with PostgreSQL. So let's just, and it's working. So I congratulate us. It's really working. So, but now let's take a look how we created this from our SQL. And here Langium also provides some abilities for code generation, how you can do it more comfortable than just concatenate many strings. So let's take a look closer. So when we define our CLI, we embed activity with generation of SQL, so this function, and then we can define it. So when our CLI will start its work, it calls this method and do what is written here. Concretely, what we are doing here, we create a new file. It has extension SQL, and then we create some node. That, usually we call it just file node. It's something where you can put everything, all content that you need, and then you content with your generated code, of course, and then you can put it inside of your file. Actually, you can do whatever you want with it. You can send it, by post to your friends, for example. It's also fine. Just what you want. Okay. But core thing that is interesting for us is how to make this conversion. So we go to conversion. Everything is here, and then you can see that what we are doing now, it really repeats shape of our RST. So when we know that this node, SQL, contains 3 different types of properties as tables, insertions, and selections. So and we just try to convert each of them. So this is what you can see. You fold it in some function to node. This is provided by Langium. That's allowed to say that your content will be in one node. And then you can go in this concrete functions, and we separately convert our tables, insertions, and selections. So how conversion of tables looks like? We take some tables like an argument, and then use some function join. So here's please take a look how it called initially. In our library it's initially called expand to node and join to node, but why not use to node and join? So here it's some function that takes all our list of our tables, and then some function that will handle each our table separately, and this function will generate some one code snippet from each table. So, and here you can already see structures that we finally get. So we have this create table, we have name of the table, we have this parentheses, and so on and so on. So then here inside, we want to handle the same way our columns. So again, we get list of our columns and use join again. Join allows us to again apply some callback to each column to get some each line. And the most tricky part now, that in SQL you want to separate it with comma, but you don't want to have comma here. So what you could do to have it automatically, to don't track that it's last element or not the last element of your list, you could use one more parameter to this join function. So you can pass separator that will be inserted exactly between elements. And finally, you can also add new lines between this. That's done exactly thanks to this functions. So similarly, you can do with conversion, with insertions and selections. So we have not so much time, so I propose to, take a look at by yourself. The most tricky part here is table, so this is very similarly. So we catched everything, and finally we can go to our main. We reached everything. So I try again this, and I hope it will work, because it worked forever. But I mean, web part, and I don't know why it didn't work. But I really want to demonstrate that it's working. Okay, it's sadness. Oh, yeah, great. So that's what you had to see just immediately. Yeah, when I tried to show it. So, yeah, you could see that actually I didn't set up anything for that. So I really demonstrated only what I did during all this development process. And I didn't set up anything with that, but it's working. Yeah, and I find it very nicely. It's nice if you want to pitch your idea to some other clients or colleagues, your idea of your language, or it looks like more impressive than just this code extension. Moreover, you can use it for further development. If you have, for example, some teams and one is working on your language and another working on deploying it, so you have already something for the team that deploys this language. So it's also nice. It's splitting of your work. Okay, and yeah, that's finally everything. We can come now to the presentation and make some conclusions. So I go a bit further, and yeah, that's everything what we did. I think it's pretty much for today, and I really hope that you enjoyed to take a look how it can be done. So let's check that we took a look at everything. So we yeah, satisfied our syntax requirements. We have everything for IDE, and we were able to convert our JavaSQL to SQL. So finally, if you want to try your forces not only in your own language development, but an improvement of Langium, I propose you to visit this page where you can take a look how you can not only develop your own language with Langium, but how you can work on Langium or work on own language and Langium together. So it also can be the case. So please check this page. And yeah, keynotes that I'd like to show about everything with Langium is that it's low, it has low barrier to entry, it's lean and customizable, and has very flexible deployment. So I propose you to try it by yourself using a Playground, so you even don't need to set up anything. Currently, we have 1 and 0 version, so it's already pretty stable. And if you want to get more information about Langium or ask questions or just communicate with us somehow, please yeah, join our dev meetings at every Wednesday at 4. Yeah, thank you for your attention.